Namaskar. Hello everyone. RVD here, and this is going to be the next video of my playlist, a course on analysis of algorithms. In the previous video I did tell you, or I did apologize for the long gap after my previous video, but here again I am with my next video, and I'll try to maintain that putting of video and putting efforts and making the things easy for you in a very regular interval of time. So before we go ahead, sincere appeal to everyone to subscribe my channel, watch the videos, like them, share it with your friends, with your fellow mates, and just try helping me in reaching to more greater audience and more significant audience as well. Okay, so let us go ahead with the current video. In the previous video we had seen omega notation. So we are currently learning asymptotic growth functions. You had seen what is asymptotic analysis. You had seen the model. You had seen that we are going to use these notations for analyzing the algorithms. So after big O and omega, the third one is the theta notation. Okay, this is the third asymptotic growth function. So when rather we want more accurate analysis, big O or omega, you had seen both are like approximate. Big O was upper bounding, omega was lower bounding. When we rather have a same function doing upper bounding as well as lower bounding, then we can very well fix up the range and we can say it's the theta. Now let's go into the definition part and all these things. Let's go ahead. So starting with the definition, theta notation, I would say f of n is theta of g of n. Now what is this function called? Like lower bounding, upper bounding and all we had seen, this is called as order function. So just because it sits between the upper and lower or best and worst, it would be mapped with the average case. Okay, actually average case has got a lot of different significance as well. Okay, so don't take it too seriously for this. Okay, so f of n is equal to theta of g of n, or else we'll say f of n is of the order of g of n. So as I just now said, that means my g of n with the help of a constant can lower bound also as well as can upper bound also. Okay, so you can clearly see it will rather be taking one constant, let's say c1. So c1 dot g of n will be lesser than or equal to f of n, whereas c2 dot g of n will be greater than or equal to f of n. But get it very clearly, even though c1, c2 are different, they are two different constants, my g of n, the function for the comparison that I had used, is same on both the sides. So f of n is of the order of g of n if and only if c1 dot g of n is less than or equal to f of n, and that is less than or equal to c2 dot g of n. So for all the values of n greater than or equal to n0. So my g of n is lower bounding as well as upper bounding. Now we have three constants here. So c1, c2 and n0 are positive constants. Okay, the graph will make the things more clear. So here my f of n is lower bounded by g of n with c1 and upper bounded by g of n with c2. So we say it is of the order of g of n. Okay, so how the graph would be? So we'll have again x-axis for number of inputs and y-axis for time. So let's say here we have 1, here we have 2, and now we obviously need to have 3. So I'm purposely keeping a single point for this. It is not necessary, get it very clearly. I can have two n0 possible values like n01, n02. Then I'll be taking the one which is greater. But I've not gone into all these things right now. I purposely made them to get into a single line. But in reality, it will never be the case, or very rarely it will be the case. You will have two different values of n0. Like first function will cut second function somewhere. So you'll have a threshold here. The second and third will have a threshold separately. But currently, this is going to be my f of n. So you can see this is, okay, pardon me, it is going a bit down. Generally it won't, it will always be a growth function. Okay, so you just try to understand the concept here. This is C1 dot G of n and this is C2 dot G of n. So f of n is bounded between them and this is my n0. Okay, or this is the threshold, sorry, which is mapped here as n0. So I will not write this is as n0, but this is the threshold. Okay, so you can clearly recollect the definition. My f of n is lower bounded by C1 dot G of n, upper bounded by C2 dot G of n. Okay, so let us try solving one problem. So we've been given f of n equal to 4n square plus 3n plus 5. So what we want to show? We want to show f of n is equal to theta of g of n, or of the order of g of n. Here g of n will obviously be n square because highest exponent term drop the coefficient. Okay, so we want to show f of n is equal to theta of n square. That's what we want to show. So by definition, it says we should have c1 dot g of n less than or equal to f of n less than or equal to c2 dot g of n. That means c1 n square should be less than or equal to 4n square plus 3n plus 5 less than or equal to, we'll have c2n square. Okay, now c1 I want to show lesser, so let me take c1 as 3 and c2 as 5. Now because I have these positive terms, you know, the lower bounding part becomes easy because 3n square less than or equal to 4n square plus 3n plus 5 less than or equal to 5n square. Now this is by default proved. Now if at all I have negative terms here, then the other side, the upper bounding side would be easy and lower bounding you require to put efforts. So you can take, maybe I'll give you some examples and you can work on it. So 4n square plus 3n plus 5 less than or equal to 5n square, that's we need to focus on, and that is going to be giving us up n0. So you can see 5n square can be shifted here, 4n square can be shifted there. So 3n plus 5 less than or equal to n square, or maybe easy for us to write n square greater than or equal to 3n plus 5. Now n square and 3n square will match at n equal to 3, but we have plus 5. So let us start checking from n equal to 4. N square will be 16 greater than or equal to 4 3s are 12 plus 5 17, which is obviously false. So I move ahead for n equal to 5. This is 25. 5 3s are 15 plus 5 20, and that is true. So that's the value of my n0. Hence proved. I would say f of n is equal to theta of n square, and when that is possible, for c1 equal to 3, c2 equal to 5, and n0 also equal to 5. Okay, so that's how we'll be able to show the example. Let's go ahead. Obviously that's the end of the video, but I'm saying go ahead because I'm going to give you the questions. Okay, so question number 1, f of n is equal to let's say 7n square minus 8n plus 2, and question 2 is let's say 10n square minus 5n plus 9. Okay, or maybe let me have both of them minus, that will be making the things easy. So minus 9. And let us have third question. So I'm giving you a lot of work. I expect maybe you to solve this, and with question numbers you can here put values of c1, c2 and n0. Okay, so question 3, maybe let us have all positive. So 6n square plus 8n plus let's say 11. Okay, so that's going to be the questions for you to try, and I expect, as I said, the values of c1, c2 and n0. So that completes the theta notation. So we have completed asymptotic growth functions, that is big O, omega and theta. I'll soon be uploading videos on the further topics. Remember, I have started with very lot of basic concepts of AOA, analysis of algorithm, and I'll be going lot in depth. Okay, we'll even see some algorithm designs like divide and conquer, greedy algorithms, dynamic programming, backtracking, and so on. And maybe the problems, the algorithms which fall under these particular algorithm designs. So I'm looking forward to a very good and interesting playlist of analysis of algorithms. Thank you for watching the video. Uh, do like the video and share it with all your acquaintances. That's it from this video. Thank you and a very happy learning.